This is section 9.6, second last question section in the textbook, techniques for solving equations and inequalities. The goal is to solve equations and inequalities that involve combinations of functions using a variety of techniques. It's a short, relatively easy section. So we have two graphs here. We don't have an investigate. We're just going straight into the problems. We have two graphs here. The blue graph is y equals cos pi over 2x. So as we know that is a horizontal stretch, and we have a fraction there before the x value. So typically we would have a period of 2 pi. Here we can see the period being a pi. So we're getting to 3.14 in one period. The other graph we have is a straight linear function, y is equal to x. Okay, and we're asked to find the point of intersection. So when we graph those two graphs out, we can see the point of intersection is right here, very close to 0.5, 0.5. Okay, but we're going to look at some strategies to how to find it exactly at this point here. Okay, we know that this graph continues infinitely in either direction, left and right, the blue graph, and likewise this red line continues, so they'll never meet again. We can see that there'll be no other intersection point between these two particular graphs. So the question says, solve the equation cos pi over 2x is equal to x to the nearest 100. So there's a few ways we can do that. Two of them involve graphing calculators, so of course we need to have that graphing app. If you haven't already downloaded one, make sure you do. We just have to know the process of finding these, okay, through our graphing calculator. The first one, however, though, is guess and test. Okay, so this is the only one we can do on paper. So if we're doing this on a test, this is going to be the one. As always, we don't have graphing calculators on the test, so you're going to need to know this method for the test. You need to know the graphing calculator methods, so conceptually, if you're given on a test two graphs, you know what to do. Okay, that's why it's important that you download that app, and we do actually go through the other strategies involving graphing. Okay, but the first one is guess and test. So what we can do is we can bring this both variables to one side. So we're going to do cos pi over 2x is equal to x. We do minus x, bringing that x over. Okay, and then simply from this point here, we start to guess x values. Okay, we have a really good idea from the graph that it's 0.5, the x values when they intersect. So if we guess 0.5, we plug it in for x here and x here, we end up with 0.207. So now we're going to go either way, right? With guess and test, we're either going to go to 0.6 or 0.4, right? So the first one they check is 0.4, and they actually get a higher value. So we went the wrong way. Okay, so then next we guess 0.6, and we get closer to 0 with 0.01. Okay, so then we guess one lower because we went into the negatives. So we're going to guess 0.59, and we get a really close value to 0. Okay, which is here. The next strategy, solution B, is the graphical strategy. Okay, so there's two ways to do it. One is you graph both independent functions and find out where they intersect, and the other one is you pull both functions to one side and set it equal to 0. You can't eat that here, okay? Thanks. So the first one, we're graphing both graphs and we're looking for the intersection point. Okay, so we can see here, there's the intersection point. If you have that feature on your calculator, graphing calculator, you can find it right away as 0.59. Or you would have to just zoom in really closely to see that value of x. Okay, solution C. The other one is we pull both functions to one side and set it equal to 0 and look for the intercept, the x-intercept. Okay, so here's the original function that we're looking to solve. We bring that negative x to one side, set that equal to 0, and now we look for our x-intercepts. Okay, so here's that combined graph. And the x-intercept is right there, which again is at 0.59. Okay? Any questions so far? So three strategies we've looked at to find intersection between two functions. The first one is guess and test. You pull both variables to one side, guess values so that it becomes closer and closer to 0. The second one is you graph both functions and you can actually look for the intercept value. And the third one is you pull both functions to one side, graph it, and look for the zeros. Okay?
So on the test, are you going to specifically asking us which methods to use
I could, yeah, I could ask you what are the 3 different methods, yeah. There wouldn't be one specific method, right? Because it really depends what you prefer to do. Each method gives you the same result, right? 0.59. All right. What are the advantages of using a guess and improvement strategy versus a graphing strategy? What are the disadvantages? So the advantage is, of course, that we can use it on a test. We don't need a graphing calculator. Okay. Disadvantage is it might take a little longer, depending, right? Graphing calculator can take a long time too, so that might be the disadvantage. When using a guess and improvement strategy, how will you know when a given value of x gives you an accurate answer? You know when it's an accurate answer when the value that you result with is very close to 0, right? When one side is very, very close to 0, when you pull both functions to one side. Which graphical strategy do you prefer? So this might be up to you. You might say the first one because you can kind of make more sense of it. You know that this is one function and this is the other function. So you might prefer this method and then looking at the intercept. Or you might say, well, I think this method is actually quicker because I only have to make one graph. Okay, so that's up to you. Example 2. According to data collected from 1996 to 2001, the average price of a new condominium in Toronto was $144,144. In 2001, it increased by 6.6% each year. A new condominium in Regina cost $72,500 on average, but prices were growing by 10% per year. If these trends continue, when will a new condominium in Regina be the same price as in Toronto? So you have to recognize right away that this is an exponential function. And like all exponential functions, we have that same formula, where we have the principal times the rate at which it's changing to the exponent of the amount of time. Okay, so it's similar to half-life. Right? So we have to know how to develop these equations from prior knowledge. Right? It's pretty straightforward though. Okay, and the only other caveat is that we're going from 2001. Okay, so we have to know that years are increased from 2001. So that's specified here at the beginning of the problem. Okay, which is pretty typical though with these problems. So 2002, then the value of x would be 1 because it's 1 year from 2001. Any questions about how these two formulas were developed from this? No? Okay. So remember, it's 1 plus the interest rate or rate of change. In this case, 6.6 is divided by 100, so that's 0.066, and 10 is divided by 100, so that's why it's 0.10. Okay? So once we've developed these two formulas, it asks us when is Regina going to be equal to Toronto. So then we set those two equations equal, and we're solving for x. Okay, this is a nice one because we can solve it algebraically. Okay, we don't have to put both of these functions into a graphing calculator because we know how to remove the variable from the exponent now. We can just use logarithms. Okay, so if we do that, we take the log of both sides. That x value drops down. Okay, and then we rearrange, and log any number is just a constant, so we rearrange and put all of our logarithms on one side, our x variable on the other, and we just use a simple scientific calculator. We can solve for the logarithms, and we find that x is approximately 21.89. Now remember, that is the time from 2001, so we would have to add that value to 2001 to get the year. Any questions there? Okay. Last one. So selecting a graphing strategy to solve an inequality. Here again, we're given two functions. One is a logarithmic function, and one is again just a straight line. It's determine when the values of x are such that this function f at x is greater than the g at x function. So we just set that into an equation, and then we can graph the equation. And there's two ways again to solve it. One is you graph both equations and you look when one function is higher than the other. Okay, or you bring them both to one side and you look when the values are greater than 0. Okay, so that's what we did here. Okay, so here's our equation. Right, we brought both equations to one side, subtract one from the other. Okay, and then we looked at the one function and we looked at the values when they're greater than 0. So between here and here. Okay, these are values that are greater than 0. And it's between negative 0.602 and 3.6. So this value here and this value here. So similarly, we did a graph, this time graphing both of them. Okay, here's the straight line, and here's the logarithmic function. And then we just looked at values when the logarithmic function was greater than the linear function. Okay, and then as you can see, they line up, they're the same values. Okay, so there's your answer. So how would have I done this without a graphing calculator? You can tell me. Sorry? Yeah, you would have to do guess and test, right? So we would have to put a value in here for x, solve this equation, and keep using different values until we get closer and closer to 0. Okay? Key ideas. Who wants to read? It's a lot to read. Yeah, okay, Lyndon, thanks.
Key ideas. The equation f of x equals g of x can be solved using a guess and improvement strategy. Estimate where the intersection of f of x and g of x will occur. Then substitute this value in both sides of the equation. Based on the outcome, adjust your estimate. Repeat this process until the desired degree of accuracy is found. If graphing technology is available, the equation f of x equals g of x can be solved by graphing the two functions and using the intersection operation to determine the point of intersection. The equation f of x equals g of x can also be solved by rewriting the equation in the form of f of x minus g of x equals 0. To obtain the corresponding function, h of x equals f of x minus g of x. The zeros of the function are also the roots of the equation. These can be determined using guess and improvement strategies when graphing technology is not available. Graphing technology can also be used to graph the function h of x equals f of x minus g of x and determine its zeros using the zero operation. Inequalities can be solved by using these strategies to solve the corresponding equation and then selecting the intervals and satisfying the inequality.
Okay, good. Need to know, the method used to solve equations and inequalities depend on the degree of accuracy required and the access to graphing technology. A solution using graphing technology will usually result in a closer approximation to the root of the equation than a solution generated by a numerical strategy with the aid of a scientific calculator. The difference between the solution to a strict inequality, f of x is greater than g of x, and an inconclusive equality, f of x is greater and equal to g of x, is that the value of each root is included in the solution to the inclusive inequality. Okay, I think this is all pretty straightforward. There's nothing in there I don't think that's not. Any questions?